In this part, we're gonna create a limb controller. This is how it's not gonna work. Okay, so it's gonna look something like this. You have your legs, and you can put them in any position you want. The same for this arm, except it's too big to actually control properly. Still works pretty good. Now, um, it's gonna be a really long video, and I'm gonna link my GitHub so you can download all the source code. And yeah, let's get started. And let's also create a list of all the parts we would use. So the list and limb part and parts. Okay, so now we would want to change this one and make it not mono behavior, and let's create a constructor. So now we would want to have a public, let's make it public for now, public rigid body to the RB, or rigid body actually, and public transform. What the fuck? Okay, so let's give it the rigid body. So this rigid body would be rigid body, and this transform would be rigid body dot transform. Okay, let's actually make it private. Okay, so now let's make another method. Let's call it public void rotate toward, and let's give it a direction. So oh, let's actually give it a world position. Yeah, and let's give it some value of force and float ratio. Now I would explain what each one would do, but for now let's leave it like this. Now we would also want to have a public void. Let's actually don't do it. Okay. Okay, never mind. Let's do it like this. So if we do public vector 2 offset, and let's say this offset is gonna be the var hinge. Okay, let's give it the hinge joint, and now let's say the hinge position connected anchor. Yeah, so this should do. And here let's say the direction is gonna be from world's position minus transformed position minus plus offset. I mean, we actually want to use offset plus, or maybe minus, but Okay, like this. Now let's also for debugging make public void on draw gizmos. Let's say gizmos dot color equals to color blue, and let's draw the offset's position so we would see if it's actually in the right place. So let's say 0.1. The same thing, but let's make it minus offset. Let's do red. Okay, so for the limb, we need to actually create all those limb parts. So the way we would do it is by making var hinge equals to get component hinge joint. Now we can actually get each part, the next part of the limb. So if we connect a limb here, like here, the next part is gonna be this upper arm, so we can get it from the hinge joint connected rigid body. So this is what we are going to do. So while hinge is not null, and hinge.transform not equals to root, we would do parts dot add new and hinge attached. Now we would want to say the hinge is the next part, so hinge dot hinge connected body dot get component and hinge joint. So this should give us all the sequence. Now on, let's actually do for each, let's just draw okay, and here let's create the target position. So public vector2 target pose, and here let's say giz color red. Now gizmos.draw sphere target pose plus transform the position and 0.1. Now again vector 2. So now we've got this. Let's say we want to move it like here. Now let's see, and yeah, so let's fix the offset issue. So first of all, we need to actually make this offset follow the rotation of the arm, and we can do it fairly simple if we just call there is a variable called transform up and right. So this is the rotated normalized value of the transform. So relative offset is gonna be offset.x times transform right plus offset.y times transform.up. So this is gonna give us the rotated x and rotated y relative to our transform. So here just change it to relative offset, and same here and same here. Now if we watch again, and we see it's fine except for this arm. So in the case of the arm, it's following the connected anchor, so it's just not the right value. It should be this anchor value. So the offset should be just anchor, and this should do it. Now let's make the arm to print us the actual angle. So public, no, I want it to be private float, and angle from direction vector to dir. Now here let's return the ACOS of dir .x, and one little thing we need to do, we need to say dir is a normalized value. So if it's great, if dir.x would be greater than 1, we would get infinity, and we don't really want it. So here let's print it. So var angle equals to angle and direction debug.log angle. Okay, let's see what we get. So we get an angle of 2. Oh, yeah, it's also a radian value, so let's just convert it to degrees. So math radian to degree, and now we would need to flip the x when the y is smaller than 0. So let's just show you what I mean. So if we go into y, if you see, it flips. So I can demonstrate it in here. So the x goes from 360 to 180, and then it flips to minus, and the same thing. So if we just take the x, we don't really know when it flips, so we do it by checking the y value. So I just say var angle gonna be this stuff, and here if dir.y is greater than 0, dir angle and 360 minus angle. Now we get the actual angle. And yeah. like this. Okay, so one thing to keep in mind in case of our hand here, this value is gonna be something like 200, but the rotation of the hand is 0 in this position, so it's actually flipped. And let's fix it real quick. So we would do it by simply creating a private bool flipped flip, and let's make it false. And here let's pass bool flipped. Now, yeah, sure. And this dot flip equal to flipped. Now, in the rotate toward, here we would say for origin is gonna be this stuff here, and in case of the actually we don't need it, so if flip, let's say direction times -1. Okay, in the limb, let's create a new public bool flipped, and let's say it's false. Now here we just pass flipped, and say it's flipped. Okay, so now we get the actual angle. Now let's rotate the arm toward this angle. So here let's do this stuff. So first of all, we want to compare this angle with the actual angle. So it's gonna be so angle is gonna be mass f delta angle. So then delta angle gives us the smallest angle between two angles. So let's say we have 350 and 0, so it's gonna give us 10 instead of 350, and this is exactly what we want. So angle and transform.Euler z. Now we can actually already transform our hand. So add torque U, and let's say angle with force. Now, oh, you get this shit. Okay. Let's make a real small force. Say 1. So here we made a mistake. It should be a reverse to angle and transform.Euler.z. So delta angles get the current and the target as the secondary. Now if we test this, yeah, it's much better. Okay, now we want to limit this angle, so we'll do it by a few steps. So first of all, let's say angle is gonna be the absolute value of angle, and we would also want to scale it down. So let's say 0.1. So the lower this value is gonna be, the better would be the result, I guess. So if angle is greater than 2, let's make angle equals 2, and here let's just say I want to do something like angle equals to angle times angle, maybe something like this. And let's also do angles 0.5f, so it would stay in the range of 0 to 2. Now we want to pass the minus value of the angle, so here if the angle was minus 10 for instance, it's just gonna be positive, so our arm would keep spinning forever. So let's say var x equals to angle greater than 0, and if so it's gonna be 1, if not minus 1. Now should be this, let's do times x. So gonna fix this next. So the problem is because both parts are moving, the direction, like the direction relative to each part is always changing really quick. So we adding too much force or angular velocity to different parts. Now, first of all, let's try to actually say there is some angular velocity. So let's say 0.5. So this is gonna scale the angular velocity to between 0 and 1 based on the angle. As you remember, the angle here is maximum value of 2. Now, it's not really helping. Maybe it's not even worth doing it. Now we need to use this ratio, so let's actually make an average direction. So vector 2 direction, say average direction, and let's say the average direction is gonna be the direction times 1 minus ratio plus plus something like average direction times the ratio. Now let's pass the average direction. Now, obviously nothing happens because this ratio is 0. Let's say it's gonna be 1. And see what would happen. So this arm stabilized and this one didn't. Why is it like this? Oh, because it's not the right arm. My bad. Okay, let's say it's gonna be 1. Okay, so if this value gonna be 0.99 and we're gonna change it, you can see it's actually working, but with a great delay. So it's the average value in 10,000 in 100 frames right now. Let's make this value a little bit bigger, and yeah, it's got a swing. So this is the last problem. We need to somehow limit those. Make this as high as possible, but as responsive as possible. So now, one way we can fix it is we can do it by a few things. First of all, something quite obvious. If we put a limbo now, a long hand here, and start it, let's add some more force. You can see the actual root has the same strength as all the other parts, and this might be an issue. So we actually want the closest part, the one that has to bear the most mass, to have more force, and just type something like let's make var index would be parts dot count, and let's say index minus minus, and here let's just do something like index times, I don't know, index plus 1 times 0.5f. Something crazy is this. Or maybe actually let's do something like plus index plus minus 1. So anything would do, just test stuff. Maybe something will work better than the other one, but in case of this hand, it's quite better. Maybe actually doing times index plus 1 times 0.5, so the first index would still be 1. Now the thing is, we actually the way I made it so far, even when our body or stickman would move, this target position would most likely stay the same and would be stabilized relative to this hand. So what we can do is we can check if we are moving this position, and if we are moving it too far, we would bump this value back to 0.9, and if we are not moving and it's stable in the same position, we would actually want to um, bring this ratio back to say like 1 or almost 1. So let's actually do this. So I would do it is the same way. Let's make an average world pose, and let's say something like, okay, world pose is gonna be um, our our average world pose would be something like world pose times some value. So let's use const float W ratio, and let's make it 0.5f, and multiply this by 1 minus W ratio, and here we would add the old average world pose and multiplied by W ratio. Now we would want to get the difference between this position and this position. So again, var diff, and let's say world pose minus average world pose. So it doesn't really matter in which, if it's world pose minus average or the other way around, because we just need the magnitude. But I would actually use the square magnitude because probably won't make a difference. So if the difference is greater than 1, let's say the difference is 1. Now again, like if this value is 1, this means they are really far apart, this world position and average world position, and if they are the same position, it would return something like 0. Now we would do something here like ratio plus equals the 1 minus ratio. So if it was 0.9, it's gonna be 0.1, and we would say times diff times some value like 0.99. So this is the maximum value the ratio would get to. So again, because now it's 1 when they are far apart, we actually want to reverse this. So let's say diff equals to 1 minus diff, and let's see what we would get. And yeah, this one looks much better. And for the, let's move the end, let's see that it's responsive. Yeah, everything works just fine. So you can see it's now like really stabilized, so this hand is moving toward this target really slow, and this looks great. Now you can actually check this out with 0.9, and maybe here say the ratio is 0.9, and it would stabilize much faster. And same for this hand. Okay, it's maybe too fast. Yeah, it's too fast. Should be 0.5. Probably the best value. So you can test whatever value wants there. Don't want it to be too high, and too low. So when you move it by a little, it's actually okay. So if we change here to magnitude, maybe it would work better. So let's actually try with magnitude. And let's see. Yeah, magnitude even works better. So yeah, this is it for this part. So now when we have I mean, we forgot one little thing. So let's see if the legs are working. So if we put a limb on the leg, I know it won't work. So let's say the leg is gonna go somewhere like here, and it won't work. Okay, so 100, and you can see it's not really working. So it's not even close, but I mean it's really stable. So the reason why it's happening is the same reason why we on the hands use the capsule with horizontal and on the legs on the vertical. So our legs are actually need the A sinus in here to work, and we can fix it really quick. Just do something like private bool. Let's make it seen, call it false, and here let's do bool seen, and again uh, let's say this dot scene is gonna be the scene value. Now in here let's actually say C angle, and it's gonna be the transform to Z. And now if this is a scene, let's say C angle minus 90. So the difference between cosinus and sinus, like here, is just 90 degrees. So whenever this is 0, it's gonna be 1, and you can see. So we just need to add minus 90 degrees in our case. Now in the limb here, let's actually create a boolean cosine. Let's make it false, and let's pass it out here too. Now again, let's go for the leg. Let's enable this. Let's say it's gonna be 100. It's gonna be 0.9. Let's say here it's gonna be 0.9. And force gonna be 100. Now let's see what would happen. And it's not working. Mm. Okay, again, what have I forgot to do? Oh, yeah, we should pass the new angle. Now let's test it out. And yeah, if it was in the other direction, we just needed to press flip or add plus 90 degrees. So the same for the next leg. So lower leg, let's put the limb. Again, let's choose the body, and I got this. Let's move this. Huh, oh, it's not pressed. Now, let's do something like this. And same with the second leg. Now, let's try to see what would happen if we move this, and as you can see, standing but no force on the hip. So in the next video we would actually use this limb controller to make him stand, walk, jump, whatever. So yeah, see you next time.